The top layer, it will go like we did on the 4x4, but we will see that we have one particularity, and we got it here, in fact. We see that this element of the cross, this edge, in fact, needs to be flipped. We need to have blue on the top. And the other elements of the cross that are here, here, there, they are correct. We cannot have this situation on a 3x3, because on a 3x3, you can flip these two. You cannot only flip one piece. Okay, so when you do the algorithm up, U prime, down, down, you flip these two elements. But there's no algorithm on 3x3 that flips only one. But on a 4x4, we can have this situation. Okay, so let's say I try to put correctly. Okay, that's not correct. Okay, green. Okay, just want to make a clear yellow face that goes here to show you the algorithm. That goes there, and that goes here. Okay, I got this face correct. So the algorithm will permit to flip only this edge and leaving the three others untouched. It goes like this. I have to move these two layers together. Okay, this is why it doesn't exist on this cube or any odd cube. It only exists on pair cubes. So you do up to U, you move all the cube, we rotate all the cube by 90 degrees to up, and then you do again up to U, up to U, then down to U, left down to U, right down to U, then up to U, down to U, up. Oh, I think I messed it. Ah, that's it. Okay. Down, down. So you see that this algorithm flipped only these two corners. Okay, I'll do it again to be clear. I will rotate or flip only these two edges, up to U, rotation, up to U, up to U, down to U, down to U, down to U, up to U, down to U, down. And I flip these two. So this is what we will do on this cube. And this situation does not exist here because here we do not have two mid layers. Here we have two mid layers. Okay, this is one of them. And the other one, which is here, I can't move it because it is blocked by the presence of this little cube here. So I have to be on a, okay, I will be on this face. I try to do the algorithm by moving these two together. And I put here this little 3x3. So let's do it just to flip this element of the edge. So it's up to U, rotate, up to U, up to U, down to U, right, left down to U, right down to U, up to U, down to U, down. And I got these two flipped, and all the elements of the cross are now correct with the blue face to the top. So this is the only difference that we could have between the top surface of this cube and this one. The other things that we could have, we already saw them on this cube. So we have, for example, we could have one corner, two, this is in its place, but we can have other corners that are not in their place. For example, this is correctly placed, this is correctly placed, but these two are not correctly placed. This belongs here and this belongs here. So we saw this situation on the 4x4 evil twin, how to exchange two adjacent corners, okay? We could also have a need to flip or to exchange two or swap two opposite corners on a diagonal. So to do that, we do what we usually do on a 3x3. It's the algorithm that goes like this. It's the one that we use to flip, in fact, the cross edges, but we do it 3 times. By doing it 3 times, we will swap these two corners, okay? This is the algorithm 1, 2 times, and 3. Okay, this is what we will do here in case we want to swap two opposite corners that are on a diagonal, let's say. But here I don't have this situation, but you could have it, and we already saw it here. Okay. Okay, I will try to do it. Okay, in order to cover all the situations. So what I will do now is, okay, these are correct, this is correct. Okay, so now what I will do is to swap this with this, but and I will get them back, but just to show you the algorithm. So it's up, you up, prime, down, down, 1, up, you prime, down, down, 2, up, you prime, down, down, 3. And as you see, this corner that was here went there, and this one that was here went there, and this one is still in its place. Okay, but I want to get them back to okay, let's say that it's not, let's continue from this situation here. This one is correct, this is in its place, and this is in its place, but these two need to be exchanged. These two are on adjacent side. So the algorithm that I will use is the following. I already used it here on the 4x4. The idea is, in fact, I repeat it, is to eject this edge from there to this layer, and then to get it back here with another algorithm. So I will kick it from its place by using the algorithm like this. And it is here. And now I will get it back to this, to its original place by using another algorithm, which is 2L U, 2L U, 2L to U, 2L to U, 2L U, 2L U prime, 2L, and I got it back here. Okay, this is what we will do, but I would like to recall what I did on this cube. We cannot start this sequence of the two algorithms having two correct or two incorrect corners here. We have to do it by having, in the first place, one correct and one that is not correct. Okay, so like this, for example, this is correct, this is not correct. this is correct, these two are correct, these two are not correct. So I start the algorithm from here, from a situation where I have one correct, one not correct corner. And I do like this, I turn it upside down to do the algorithm that I do on a 3x3. I move back, down, forward, up, forward, down, back, up. And I kicked this orange and white from its position. Now I will bring it back to its position by exchanging these two edges with 2L, U, 2L, U, 2L to U, 2L to U, 2L, U, 2L, U prime, 2L, and I got it back here. Now let's move to the top. On the top, I see that I need first to flip these two corners using the algorithm that flips corners up, U prime, down, down. And the corners are now flipped correctly. Okay, so this is in its place. This is in its place. These two corners need to be exchanged or swapped. And I will do it by repeating 3 times the algorithm that I just did to flip, in fact, the elements of the corner. So I will do it 3 times. It will not impact, because I do it 3 times, it will not impact the fact that blue will stay on the top, but it will exchange these two. Let's do it. Up, U, up, U prime, down, down, 1, up, U prime, down, down, 2, up, U prime, down, down, 3. And if I take a look now at my puzzle, I see that this is correctly placed, this corner, this is correctly placed, this is in its place, it only needs to be flipped, and this is in its place and it needs to be flipped. So to flip, we already saw how we flip corners on this. Okay, I put the two correct blue here, and I do the algorithm of up to U, down, U, up, U, down. And I put the blue right correct corner here, and now I will flip these 3, up, U, to U, down, U, up, U, down. And now the correct one, I put it again here, and this last time I will flip this, and this, and they will be correctly flipped with blue on the top. Up to U, down, U, up, U, down. Okay, I got these blue correct, and all the corners are correctly placed. Okay. Now what I need to do is to exchange this with that, and this with that. 2L to U, 2L to U. And then I will exchange yellow with orange. 2L U, 2L U, 2L to U, 2L to U, 2L U, 2L U prime, 2L. Okay. So I have solved the puzzle, except that I still have these two to be exchanged, and they could be exchanged, but the problem is the same that we encountered on this puzzle and what we called a parity problem. In fact, if I do the exchange, I will reverse this 2L to U. Okay, I solved the top, but I reversed this midline, and I need to get it back to this position. So I will repeat this algorithm. To U, to L, to U, to L, to U. Okay. So we need, in fact, to have one more exchange on the top and do two algorithms that do exchanges of edges so that the reverse situation will not be produced. What we did on this one is that we exchanged, in fact, we had the center here, we exchanged one element of the center with another, okay? It doesn't change the solution of the centers, but it creates another exchange on the top layer, and this will solve our problem. So this is what we will do here. We will try to exchange white centers with white centers. So the white centers are, in fact, they are here, okay? And not these. These are, in fact, are edges. This is an edge. This is an edge, okay? And no, these, the centers are here. This, and this. No, it's here. Here are the centers. Okay, it's not very evident to see them because they all look alike. In fact, you have to see that this can move, so this is a center, and this can move, so this is a center. And the center, in fact, is around these edges, blue, white, and orange, white. So these are and these are not centers. In fact, these, look, these move away, and this piece is attached to this one. This is attached to this. This is attached to this. So these are not centers. Okay. So centers are along the blue and orange. So what we should do here, the difference between this and this is that we have to move the centers by two layers like this. Okay. So let's recall that my centers are blue, okay, that could do it. Okay, so I have to move by two layers like this, and not only one layer. Here we moved one layer, but here we have to move two layers and then get this like this, and we will have to exchange these two with these two like this. Okay, this is how we'll proceed. This is the only difference for exchange of centers between this cube and this one. Here we have to move two layers. So let's do it. It's 2L U, and we move two layers. 2L U, 2L 2U, 2L 2U, 2L U, 2L. And here we see that do not continue the algorithm. You stop here and you see that all these are correct except that I need to place the green down. So I push it away, I move 2, and I put it down. And I have solved the cross. I have the cross, I have the cross. All I need is to place the corners again by placing this here. So it's 2L U, 2L U prime, 2L, and then I will put this there, 2R U, 2R U prime, 2R. Okay, so I did not disturb this, but on the top, as you see, I have created another exchange. I can exchange yellow with white, so I get this solved, and then I can exchange white with orange here, and I have created a double situation of exchange, and I will not have the reverse problem that I had in the first place. So let's do it. I will put the white here, 2L to U, 2L to U, 2L to U. I got the white solved. I have reversed this layer, but it's not a problem right now because I will get it back reversed to its normal situation when I exchange this and this by 2L U, 2L U, 2L to U, 2L to U, 2L U, 2L U prime, 2L, and the puzzle is solved. And I think I have covered all the situations that we could encounter on the top layer.